Hi. In today's lecture, we will start with a new chapter of inorganic chemistry, D and F block elements, right? And before we start with D and F block elements, you should be good with periodic table, right? That we have done in general chemistry, right? So periodic table understanding should be very good in order to understand D and F block elements, right? Quickly and easily. So D and F block elements, like we have studied S block elements. In S block elements, the last electron enters the S orbital. In P block elements, right, which comes here in the periodic table, the last electron enters the P orbital, right? Similarly, in case of D block elements, the last electron will go into your D orbital, right? When we say last electron goes into D orbital, it is while writing electronic configuration. That means if you write down the electronic configuration of a D block element, the last electron will go into the D orbital while writing down the electronic configuration, right? So when you start with D block elements, the D block elements scandium, it starts with atomic number 21, right? It will come somewhere here, right, in fourth period of the periodic table, right? In scandium, atomic number 21, you will start filling the D orbital as per the normal rules of filling or writing down electronic configuration, right? So D block elements, first of all, in D block elements, last electron enters D orbital. One thing to remember here is the last electron will enter D orbital of penultimate shell. Penultimate shell means the shell before the valence shell, or the shell, one shell before the outermost shell, right? So last electron will enter D orbital of penultimate shell, right? That means if you have total of n shells, right, then last electron in case of D block elements will go into D orbital of penultimate shell. Penultimate shell is one shell before the last shell, the ultimate shell, right? It would be this. So last electron will enter into n-1 D orbital, right? So these would come under D block elements, right? Or we also call these as transition elements. So we'll understand why we call these as transition elements, right? And the D block, if you look into the periodic table, this middle section, right, this middle section which is between your S block and P block is your D block element, right? So D block elements come under D block of modern periodic table, right? I'm just writing MPT, modern periodic table, right? And it starts with atomic number 21, right? And its electronic configuration, the general electronic configuration of transition elements would be your n-1 D 1 to 10, because we know that D subshell, we have 5 D orbitals based on the orientations, and each orbital can have 2 electrons, right? So 5 orbitals will have 10 electrons. That is why D orbitals can have electrons 1 to 10, right? Then your ns2, because S orbital can have maximum of 2 electrons. So this is the general electronic configuration of D block elements, right? And it starts with atomic number 21, which is your element scandium, right? This is your element scandium, right? Now it starts in the periodic table. D block elements starts from fourth period, to seventh period, right? So somewhere here from 4th period, right, to your 7th period, right. 7th period, periods are horizontal rows, right. So all elements from 4th period to 7th period are your D block elements, right. So if we talk about 4th period, just a little on periodic table. 4th period means the maximum number of shells, right, would be 4. That is, this n would be your 4, right. So the last electron will go to 3d orbital, right, based on this. Similarly, for 5th period, this n would be 5. Then your penultimate shell would be n minus 1, 4, right. So last electron will go to 4d subshell or 4d orbital, right. So starts from this, and let me just show you the electronic configuration of scandium. It would be 1s2, 2s2, 2p6, 3s2, right. Its atomic number is 21, right. So it would be 4, then comes your 4s2, then comes your 3d1, right. But for the sake of simplicity, we write this is of this 3d orbital is of 3rd shell, right. So let's write it like this: 3d1, 4s1, right. So last electron is going to your n minus 1. Your total shells are 4 shells. So last electron will go to 4 minus 1, 3d orbital, right. So this is your last electron, right. Similarly, if we talk, this is your scandium, right. Now the next element is your titanium in this series. Titanium, it would be 1s2, 2s2, 2p6, 3s2, right. Then in this case, the last electron will again go to your 3d only, right, because titanium also belongs to 4th period, right. So electronic configuration would be, I'm sorry, here it should be 4s2. It's 4s2 here, right. It would be 3d2, 4s2, right. Similarly, you have vanadium after this. Everything would be same. It would be 3d3 and 4s2, right. So just notice here, the differentiating electron, which is the last electron, enters the d orbital of penultimate shell, right. So your differentiating electron enters n minus 1 d orbital. It would be here. In case of 4th period, for 4th period you have n is equals to 4, right. This scandium, titanium, vanadium belongs to 4th period. Like I said, it starts from 4th period only. So n minus 1 d would be, it's your n minus 1 d would be your 3d, right. So in case of 4th period, your 3d orbital will start filling up, right. So you will see here 3d4, after this the element after vanadium 3d4, 4s2, like this it will continue, right. So I hope till this point it is clear. And now the other important thing is that since this D block elements lie between S block elements and your P block elements, right? We know that S block elements are highly electropositive, right? And they form ionic compounds because they can easily lose out electrons, right? And your P block elements are least electronegative, so they form covalent bonds, right? And we call these D block elements as transition elements because their properties are between S and P block elements, right? So their electropositive nature would be between S block elements, it would be since your electropositive nature is decreasing in this direction, it would be less than S block elements but more than P block elements, right? So your properties are transitioning, right, in this direction from S block to P block, right? Like we said that S block elements are highly electropositive and P block elements are your least electropositive. So your transition elements, as you keep moving towards P block element, this electropositivity will keep on decreasing, right? So it will keep on transitioning, right, towards least electropositive elements, right, of P block. That is why we call D block elements are as transition elements, right, because their properties transition from S block to P block. That is one of the property, like electropositivity will transition from higher to lower towards P block, right? So we call these as D block elements. D block elements are your transition elements. These are your transition elements, right? And now we know the reason why we call these as transition elements, because their properties transition, right? And like I said, these start from 4th period till 7th period, right? We will start from 4th period till 7th period, right? So last electron in case of 4th period will go to, for 4th period n is equals to 4, right? So n minus 1 d would be your 3d, right? Now if we talk about 5th period, talk about 5th period, n is equals to, 5th period means the elements of 5th period will have 5 shells. So outermost shell would be number 5. So n minus 1 d, where your last electron will enter, would be 4d. Similarly, 6th period, n is equals to 6. n minus 1 d is equals to 5d. Similarly, for 7th period, n is equals to 7. n minus 1 d is equals to 6d. Right? So in case of 4th period, the last electron, the differentiating electron will enter the 3d orbital. In case of 5th period, it will enter to 4d. It will enter into 4d orbital. In the 7th period, in the elements of 7th period, the last electron will enter into your 6d orbital. Right? So based on where the last electron enters, these transition elements are classified into 3d series, 4d series, 6d series, and 5d series and 6d series, right? So these are series into which transition elements are classified. This is the classification of transition elements, the D block elements, right? I hope this is clear, right? Just remember the classification, right? And just understand that in these elements, these elements starts from atomic number 21, right? Where you start filling up 3d orbital, right? As per the normal rules of writing down electronic configuration, right? So in transition elements, you will start filling up the last electron in your 3d orbital, right, or your d orbital. Since your last electron is going into your d orbital, so you call these elements as d block elements, right? And we call these elements as transition elements because these lie between S block elements and P block elements, right? So their properties transition, right? If you move from your S block of the periodic table to P block of the periodic table, right? I hope till this point it is clear, right? Classification is done. Now let's talk a little about F block elements, right? And just remember the general electronic configuration, it would be this, right? N minus 1, D 1 to 10, and S 2. right? Now F block elements would be in the periodic table. In the modern periodic table, you will see a different block like this that consists of two horizontal rows, right? These two horizontal rows constitute F block, right? These are F block elements, and they constitute lanthanoids and actinoids. The first series would be your lanthanoid, and the below row would be your actinoids, right? So these are your lanthanoids and your actinoids. And the important thing to remember here is that these are your 4F and 5F series. The lanthanoids come under 4F series and this come under 5F series, right? And in lanthanoids and actinoids, your last electron will go to n-2 F orbitals. F orbitals can have maximum of 14 electrons. So F orbital will contain 1 to 14 electrons, right? So this would be the general electronic configuration of F block elements, right? And we'll talk more about F block elements in another lecture, right? So these are also called as, since the elements are going to the inner shell, right? Inner shell of it's going to the inner shell, right? So we call these as inner. This is the inner shell of penultimate shell. This is n-2. If the outermost shell is n, then the last electron will go to F orbital of your inner shell of penultimate shell, right? That is one before penultimate shell, right? That is why we call these as inner transition elements. We call these as inner transition elements, right? And just remember their electronic configuration. It would be n-2, right? F1 to 14, n-1, D0 to 1, and ns2, right? So from these F block elements, you will start filling up F orbitals, right? I hope this is clear. And it starts with cerium, right? 4f1, 5d1, 6s2. It starts with cerium, 4f1, 5d1, 6s2, right? That is why this is your 4f series, right? And actinoids would be thorium, right? Actinoids, this actinoid, it will start from thorium, right? And electronic configuration would be 5f1, right? Then you have 6d1, 7s2, right? Just understand these small things. And that's why we call these as 5F series. Actinoids come under 5F series because we start filling up F orbital of 5th shell. That is why we call these as 5F series. Actinoids come under 5F series. Lanthanoids come under 4F series because the element cerium, the first element of lanthanoids, we start filling up the F orbital of 4th shell, right? And why we call these as inner transition elements? Because the last electron goes to the inner shell of penultimate shell, right? So one before penultimate shell. So this starts with lanthanoid starts with cerium, and your thorium starts with your actinoid starts with thorium, right? And atomic number of cerium is 140 and thorium is 232. Right? So just you can take down all these notes, right? And just understand the classification, your electronic configuration, right? The series, right? How we done which electron goes to in one complete row of 4th period. The last electron will always go to your 3d orbital, right? Similarly, in case of 5th period, right, the last electron will always go to 4d orbital. So we call the elements of fifth period would be called as 4D series, right? It's a 4D series of transition elements because your last electron will enter into 4D orbital, right? Similarly, this is your fifth D series, right? So all elements of sixth period are called transition elements of 5D series because your last electron, which is your differentiating electron, will enter into the fifth orbital, the d orbital of fifth shell, right? And differentiating electron, what is a differentiating electron? It differentiates element from the element before it, right? For example, if here the last electron enters into 3d orbital, the last electron is the first electron, right? So the last electron is a differentiating electron. It will differentiate your this element from this element, right? That is, it will differentiate titanium from scandium, right? If the last electron will differentiate these two elements, because if you have one electron in titanium, then these two elements would be same, right? So the last electron will differentiate the two elements. That is why this is a differentiating electron. The last electron is also called as the differentiating electron, right? So from next lecture we will start talking about properties of transition elements, because transition elements are important. We have very important elements like royal elements, silver, gold, right, in this series, right, of D block elements. And we have very important elements which are used in industrial processes like iron, copper, right? All these are used as catalyst in many of the industrial processes, right? So I hope all this is clear. Now from next lecture we'll talk more about transition elements, and we'll talk about some exceptional configuration in the next lecture, and then we'll also look into a different definition of transition elements, right? Like the elements that have partially filled d orbitals, they are only transition elements. If you have completely filled d orbitals, they are not true transition elements, right? We'll see that in next lecture. Thanks.